This is the screencast for section 2.4, example 2. The remainder and factor theorems seem extremely easy, and I'm not going to lie, they're not the most complicated thing we're going to tackle in this course. But what happens is students seem to forget about them on the test. These are two very key ways to get some very quick answers in a short amount of time. If you forget about them, you could end up doing a lot of work. So please remember these and keep these fresh in your head. Example 2. Use the remainder theorem. So the remainder theorem says if a polynomial f of x is divided by x minus k, so like x minus 2, x minus 3, x plus 4, then the remainder r is f after you plug in the k value. So in example 2, it says just find the remainder. That's all we have to find is the remainder. You don't have to go through long division. You don't have to go through synthetic division. All you need to do is find f of k. In this case, k equals 2. So f of 2 is 3 times 2 squared plus 7 times 2 minus 20. Which then is, let's see, 4 times 3 is 12, plus 14 is 26, minus 20, negative, nope, just 6. So the remainder is 6. So 3x squared plus 7x minus 20 divided by x minus 2 will eventually have the remainder of 6. Part B asks for the remainder of x plus 1. Well, this k value is negative 1, so I need to plug in negative 1 to the function. And that will be able to get, that will get me the remainder. So negative 1 squared is positive 1. 3 plus, minus 7 is negative 4 minus 20. So the remainder is negative 24. So negative 24 is the remainder of f when f of x is divided by x plus 1. Part C, you guessed it, plug in negative 4. The k value here is negative 4. This is x minus negative 4, which resulted in the positive 4. So we have 3 times negative 4 squared plus 7 times negative 4 minus 20 equals, oh, that's going to be hard to do in my head. Now, luckily for me, I have my calculator sitting right here, plug that in, and I get actually a remainder 0, which means that this function divides by x plus 4 evenly. There is no remainder. As a matter of fact, we can look here at the factor theorem. A polynomial function f of x has a factor x minus k if and only if f of k equals 0. So since f of negative 4 equals 0, x plus 4 is a factor of f of x. The now try problem for example 2 is number 13. The remainder theorem. So to find the remainder when f of x is divided by x minus k. So this one, they just give you k. K is 2. That doesn't get much easier than that, so you just have to plug in 2. And f of 2 is 3. So the remainder of f of x divided by x minus 2, the k value is 2, is 3.